everyone, thank you so much for coming to this video. So today we're going to be going over outliers. So the learning objective for today is to be able to recognise and interpret possible outliers in datasets. So please refer back to the video on measures of central tendency, as that will come into use for this video. But let's get started. So first you need to know what a definition of an outlier is. So there are two ways to define an outlier using measures of central tendency. The first one is an outlier is something that a value that is more than 1.5 times the interquartile range above the upper quartile or below the lower quartile. And the second definition of an outlier is one that is more than 2 times the standard deviation of the mean. So you just need to memorize these two ways of finding out what outlier is. So outliers can measure affect the measure of variation. So this is because it can make the variance much larger than it would be otherwise. So this is because if there is an outlier if there's a value that's more than 1.5 times it or 2 times the standard deviation of the mean, then that means your variance would be stretched a lot, it'll be a lot larger. So therefore, if a data set does contain outliers, then a better measure of variation is probably the interquartile range, because your outliers don't actually directly affect your lower quartile or your upper quartile, but they can directly influence your variance. So let's try to apply this to this question here. Feel free to pause the video and try it out for yourself. So we have the lower and upper quartiles of a data set are 70 and 100. We want to decide whether the data values 30 and 210 are outliers. So the first thing you want to do is decide which definition of outliers we want to use. So because they've given us the lower and upper quartile, we can use the interquartile range because we can figure that out. So we know that interquartile range is just your upper quartile minus your lower quartile, which is just 100, minus 70, which is just equal to 30. So now we can work out our lower fence of outliers. So that would just be 70, so your lower quartile, minus 1.5 times your interquartile range, and that's just equal to 25. And if we do our upper fence, so it would be from your upper quartile, add 1.5 times your interquartile range, which is 30, which is equal to 145. So now we want to decide whether 30 and 210 are outliers. So our lower fence of outliers is 25, which means any value that is lower than 25, this would be they would be recognized as outliers. But 30 is more than 25, so therefore 30 is not an outlier. And then we also have our upper fence as 145. So that means any value that's above 145 are recognized as outliers. So 2110 is above 145. So that means that 2110 is an outlier. Okay, so this is how you can figure out whether or not your values are outliers. You just want to find your interquartile range, and you want to do your lower quartile minus 1.5 times of your interquartile range. And then for your lower value of outlier, if that's below your that value that you just got, 25, then it's an outlier. If it's above, it's not. Then you want to work out your upper fence outlier, which is just your upper quartile plus 1.5 times your interquartile range. And if a value is above that value that you just got of 145, then it's an outlier. If it's below, then it's not. So now let's try an exam style question to put this into practice. So we have an exam question here. Feel free to pause the video and try it out for yourself. So we have, in a study of how students use their mobile telephones, the phone usage of a random sample of 11 students was examined for a particular week. The total length of calls y minutes for the 11 students were these values. So the first thing is we want to find the median and quartiles for this data. So to find the median, we want to find the position of the median first. So it'll be 11 plus 1 over 2, which is 6. So we want to find the sixth value in our sequence, which is in order already. So it'll be 1, 2, 3, 4, 5, 6. So our median is just 53. Next, we want to find our lower quartile. So that would be 11, our position would be 11 plus 1 divided by 4, which is just 3. So you find our third value, which is just 35. So our lower quartile is just 35. Then our upper quartile would be 11 plus 1 over 4 times 3, which is just 9. Your upper quartile is your ninth position, which is just 1, 2, 3, 4, 5, 6, 7, 8, 9, which is just 60. So that's all your median and quartiles. Now if we move on to part B, it says a value that is greater than Q3 plus 1.5 times Q3 minus 1 or smaller than Q1 minus 1.5 times Q3 minus Q1 is defined as an outlier. We want to show that 110 is the only outlier. So lucky for you, they've given you the definitions of outliers. You don't need to memorize this yourself. So let's just use this. So Q3, that's the same as your upper quartile. So let's find out your upper fence for outliers first. So that'll be 60 plus 1.5 times 60 minus 35, which is just 97.5. Then if we do our lower fence, Q1, which is our lower quartile, so 35 minus 1.5 times 60 minus 35, which is just minus 2.5. So the range that your values can be that aren't outliers is between minus 2.5 and 97.5. So the only value that you have outside your range is 110. So you could say 110 only value outside range. So therefore 110 is the only outlier. That's your answer to this question. That's everything. Thank you so much, everyone. Hopefully you now understand how to recognize and interpret possible outliers in data sets. So make sure you do some practice questions just to make sure you fully understand everything that we've covered.